Okay, if you'd like to turn back to page 11, we're going to move on to working out the equation of a straight line. So what we've done to this point is we have worked out our gradient using our rise over run, okay, and making a little triangle to work out that slope. The next stage that we've done is that we've had 2 points along a line, and using the gradient formula you have learnt how to work out between these 2 points what the gradient actually is. So the next thing that we're going to do is try and identify from a formula that all straight lines have what our gradient and then what our y-intercept would be. So our y-intercept is where it crosses our y-axis. So the general formula for a straight line looks like this: y equals ax plus b. The a is always our gradient, and so this is the number that is next to the x term, or you would consider that to be multiplied to the x term. The other one is our y-intercept, and that is always the number, and in this case it's added to the x term, or it could be in some other cases like over here subtracted from the x term. So this is the general formula, and all straight lines can fit into this. And if you put your x term first and then your number term in that format, you'll be able to work out your gradient and your y-intercept. So let's have a look. We've got these 4 examples here. Y equals 3x minus 2. So the number next to the x term is our gradient, so it's got a gradient of 3. So you would write a equals 3. That's the symbol for gradient. And it's got a y-intercept of minus 2. So the symbol for y-intercept is minus 2. So in the first exercise that I'm going to get you to do, all you need to do is identify the gradient and the y-intercept. But just for the purposes of how you can start to picture what the line is, I've added in, and you could add in to the bottom of your page, an axis. So I always start to get a picture of what it looks like. Okay, so the minus 2 tells me that it's going to cross the axis at this point. Okay, so that point would be 0, minus 2. Okay, it also tells me it's got a gradient of 3. So if I was to go across 1, I would 1, 2, rise 3. Go across 1 from that same point, rise 3. Then I can start to visualize what this actually looks like. Okay, and you can start to get an idea. It's a little bit not steep enough, but it would look something like that. Okay, so let's have a look at the next one. We've got y equals minus x plus 4. So we remember that minus 1, okay, we never actually write that, it's assumed. So that's actually got a minus 1 sign there. So our gradient is equal to minus 1, and where it crosses the axis, the y-axis, is at plus 4. So it would cross about here if we were to ask to draw it, and as we go across 1, it's going to go down 1 unit, across 1 from that point, down a unit. So you can start to see what the slope of the line looks like, and if you drew it in, it would look across like that. Let's have a look at the next one. These are some examples where you don't necessarily have all the parts, or it appears that all the parts are in your equation. So let's have a look. We've got y equals 5x. So we've got our gradient of 5, and then there's nothing there. Okay, so that would tell you it would be equal to plus 0. So that would tell you that it would go through the origin at 0. And it's quite a steep line. We'd go up, every time we go across 1, we'd go up 5. So it would be coming down like that. Let's have a look at this one. Y equals 6. There's no x term. Okay, so that must mean that our gradient up here is equal to 0, because if we rewrote that, y equals ax plus b, our general equation, if a was equal to 0, it'd be 0 times x, and our 6 there for our y-intercept. And so this would end up being nothing, it'd be 0, and so that's how we come up with y equals 6. So that tells you that it hasn't got a gradient. So have a think about what that line might look like if it doesn't have a gradient. It would be a flat line, and it would probably sit up somewhere like this at position 6. Okay, so these are some of the exceptions. So make sure that you remember those ones. Come back to this page 11 when you need to. So let's go through some together. We've got on the next page y equals 5x minus 2. Okay, so you might want to highlight what your gradients are. Okay, they're always the number that's multiplied to the x. They do not include the x, just the number. And then you might want to highlight including the signs, likewise including the signs with your gradients, all your y-intercepts. Okay, so for this one, our gradient is 5 and our y-intercept is negative 2. For this one, our gradient is equal to negative 2 and our y-intercept equals positive 8. And for the last one, our gradient is equal to 2.5 and our y-intercept, there's nothing there, so it must be going through the origin. And you could potentially start to draw these like I did on the page before. The next step is for you to now write the equation of the line, given that you're given the gradient and the y-intercept. So this is our general equation, remembering this is our gradient and this is our y-intercept, and you just need to put the numbers where you see the relevant symbol that matches that. So it becomes 3x, our y-intercept is plus 2. Our gradient for the next one has minus 2, so we put minus 2 there, x, and our y-intercept is 0, so it would be plus 0, but we leave that out, so our real answer would be y equals negative 2x, and it just goes through the origin. And our last example has a gradient of 1 and a y-intercept of positive 3. And so just to rewrite that with convention, we take out the 1, and so there are all our equations for lines. So I'd like you to have a go on page 39 this time. So question 7 is just identifying the gradient and the y-intercept like these first examples. And then question 8 is like writing the equation of the line given the gradient and the y-intercept. Okay. Okay, have a go at those.